Last two examples, I just thought I'd break it into a third video for you if you wanted to try it on your own. Let me just erase the nitrate. We'll do the carbonate and the nitrate. So as the last thing I said to you was add the electrons to the valence. All right, but we're going to do, I've hidden the steps because we've gone through them a number of times, but let's go through this whole process. So how do we handle the structure? Within the polyatomic ion, there are covalent bonds. So we have carbon, we have oxygen, and we have negative charge, right? Let's circle the charge. So we have one carbon, we have 3 oxygens, and we have 2 negative charges. Carbon has 4 electrons, so we just add the electrons to the valence. Oxygen has 6 electrons, and of course there's 2 charges. Each charge is 1 electron, so this is 4 plus 18, whoops, that should be an equal, and 2, that means there's 24 electrons over 2 is 12 pairs. Okay, so now let's draw this. We have carbon. I like to draw things symmetrically. Oxygen, it doesn't really matter. You could draw them whatever you want, but you don't have to point them to the corners of a triangle. And then we have, so now we have my remaining pairs. Is I had 12. I've used 3, so that means I have 9 pairs. Right, so like I said, we redraw carbon. Actually, I'm not going to draw them to the corners of a triangle here. It's easier to do it this way. So now to put the 9 pairs in, outside atoms first. 1, 2, 3, 4, 5, 6. Count with me. I can hear you. 7, 8, 9. All right, so all 9 pairs are in the structure. There should be a total of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, now we can check each one. 1, 2, 3, 4. 1, 2, 3, we're checking the valences. All the oxygens have 4. After you do a bunch of these, you'll be able to recognize patterns. It's always good to look for patterns in the sciences. There's only 3. So what do? We do what we've done before. We're going to take arbitrarily, whoops, I don't know what I just did. Arbitrarily, we're going to take one of these. So I'm going to draw it over here. All right, and let's put the bonds in. There's now a double bond on this side. These ones we didn't change, and these ones we didn't change. Now we can check. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And the carbon has 1, 2, 3, 4. So it's done. Now what you should do, anytime you're done with a structure, just ask yourself, does it have resonance? And you're looking for atoms, the same 2 atoms bound together but differently. So carbon, oxygen, single, carbon, oxygen, single, carbon, oxygen, double. That means it has resonance. So the way you do it is you just redraw it and put the double bond here. You can literally think of just turning it, kind of like just rotate it like that. So, and what we use is we use a double-headed arrow. And so if I just move these, so now let's just turn it a little bit. Try to squeeze them all in here. We'll put the double bond here. Notice that the double bond only has 2 unshared pairs. And this one will have a 3rd. Resonance is one of the things that in Chem 152, it's, oh, by the way, that you need to recognize it. But as you progress, it's going to become more and more important. Electronegativity, we talked about with the periodic table, is that way. Right? And then what we do is we put the whole thing, whoops, in brackets, like this. Kind of sloppy. And then just put the charge on the outside. There is a way to tell where the charge is. That's called formal charge. Your textbook does that. I'm not going to do that in this class. I think that's one thing too many. I think this is what we have is plenty. All right, so give yourself a moment, hit pause on the video, get a look at this, do whatever you need to do so you can save it. And I'm going to do one more. We'll do the nitrate ion. Try the nitrate ion on your own, NO3 minus. Okay, I'll put it up here. This will be the last one. All right, so like I said, try it on your own if you want, if you're feeling bold. Whoops, NO3 minus. Okay, like I said, hit pause, give it a go. But I'm going to walk through it. So again, same idea. N, O, and there's negative charge. There's 1 nitrogen, there's 3 oxygens, and there's 1 negative charge. Nitrogen has 5 electrons in the valence. Oxygen has 6 electrons in the valence. And every negative charge is an electron. So this is 5, this is 18, and this is 1. So that's 18 and 6 is 24. That's a 4. Equals 12 pairs. What's the central atom going to be? You guessed it, it's going to be nitrogen. Then we'll attach the oxygens, O, O, O. Okay. Now we check the remaining pairs. You see, even I've been doing this for a million years. I do this step by step, right? So we have 12. And as I get older, I'm finding I need to do things step by step more than I did when I was younger. I've used 3. Right, so I have 9 pairs left. Very similar to the carbonate. One, 2, 3, 4, 5, 6, 7, 8, 9. All right. Now everything's in the structure. We have 12 pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We check the valences. This has 4. 1, 2, 3, 4. 1, 2, 3, 4. The nitrogen only has 3, so arbitrarily I'll use this one. Doesn't really matter. So let's redraw it. I moved that pair, so now I have this. Okay, will it have resonance? Will I have nitrogen, oxygen, zinc? Yes, it will. So we're just going to turn it. So the next structure, double-headed arrow for resonance. Why? Because in the meeting, that's what was decided. So this has the double. Single has 3 unshared pairs. The single has 3 unshared pairs. And then we have a third structure where the double bond could be on the left. So we'll put the double bond here. It doesn't matter where on the atom you put the unshared pairs, because realistically. All right, so those are the 3 possibilities. Put the whole thing in brackets and put a negative on the outside. All right, so I've done, let's see, methane, ammonia, water, carbon dioxide, carbon monoxide, sulfur dioxide, nitrate, and carbonate. So I've done 8 examples for you. That should, I think several of them are on the homework, so you should be able to do that. The next lecture coming up is molecular geometry, which is shape, and that will be the last lecture. Have a good one. If you have questions, I'm always available on Zoom Monday through Thursday, 8 to 12.